In this video we're going to talk about oxoacids. Oxoacids are simply acids that contain a hydrogen bonded to an oxygen. And it's that hydrogen that's bonded to the oxygen that's leaving and going into solution to give us that acid property. So there's two different types of oxoacids. There's one with the general structure of HOY, where Y is another element. And typically, the structure is that the hydrogen is bonded to the oxygen, is bonded to the other element, and we're going to look at those halogens, examples of halogens where Y is equal to chlorine, bromine, or iodine. And what we see is that as the electronegativity of the element that's bonded to the oxygen increases, the acid strength increases. And the reason that is because that element that atom is able to pull electron density away from the hydrogen-oxygen bond, thereby weakening that bond and making the hydrogen easier to leave, which gives us then the stronger acid. And as you recall, the electronegativity decreases down a group in the periodic table. So the electronegativity of chlorine is greater than bromine, is greater than iodine. So what we should see is that the acid strength of HOCl is greater than HOBr, is greater than HIO, or whatever order you want to put those elements in. Okay, so the other way we can look at this is with electrostatic potential maps. And so in these two maps, we're showing the hydrogen bonded to the oxygen and then bonded to the other atom. So this is with chlorine, this is with bromine. Now it's actually kind of hard to see in these two electrostatic potential maps, but there's just a slight amount of orange color here underneath this hydrogen atom. So the orientation of the molecule is the same in both of these images. What you would expect to see is that there's a more blue region over the hydrogen where the bond strength is lower, and that's in this example with the chlorine, as opposed to the example with the bromine. Now it's a little difficult to see that here in these figures, but in fact that is the case, and this hydrogen is easier to ionize, it's easier to leave. The other type of oxoacids are those that have multiple oxygen atoms, so HYO sub N, where N could be 1, 2, 3, or 4. So you'll have HClO, HClO2, HClO3, and HClO4. And what we see is that the acid strength increases as the number of oxygen atoms increases. And again, this is because those oxygen atoms are able to pull electron density away from that hydrogen atom. It's still a hydrogen-oxygen bond, but it's able to pull electron density away from that hydrogen atom, making that hydrogen easier to leave. Okay, and we know that HClO4 is a strong acid, okay, and so that is the strongest acid. We'll talk about pKs later, so you can ignore that in this video for now. But you can see again with the electrostatic potential maps, again the red is the electron-rich area, the blue is the electron-poor area. Those with the strongest those that are the strongest acids have a more blue region around the hydrogen that's leaving, and so this is HClO4. Here are 4 oxygen atoms. This has a more blue region around the hydrogen than does HClO. So again, as the number of oxygen atoms increases, the acid strength increases.